Okay, quick little video here on similar polygons. Two polygons are similar if one could be obtained from the other by a dilation or a dilation with one or more rigid transformations. That's a big sentence. In general, if they're the same shape, they're similar. Okay, they don't have to be the same size, but if they're the same shape, they are similar. That doesn't mean two triangles. That means the two triangles look the same as well. So if one of them is like that and the other one is like that, I understand they're the same shape, but they need to be also like, they need to look the same. A similarity transformation occurs when a figure and its image have the same shape but not necessarily the same size. For example, a dilation would make it a similar triangle. Okay, so here is our key concept, similar polygons. Basically, the only thing that you need to get from this is that all of our angles are going to be congruent. Every single angle that is corresponding is congruent. So A and W, for example, are congruent. And then our sides make ratios. So all of those ratios are going to be exactly the same. So for example, 15 divided by 5 is 3. 12 divided by 4 is 3. 21 divided by 7 is 3, and 18 divided by 6 is 3. They all have the same ratio. Another word that we like to call that is scale factor. So the ratios are, it's just basically saying that's what your scale factor is. So my scale factor of the first one was 3. Now it's important to remember before we move on, we want to take the first one that they show us and put it on top every time. So if they don't say which one is going to which one, put the first one you see on top. Here's our example 1. I'm going to zoom in. It's going to I wrote in these previous to making the video. As you can see from the colors and the lines, you can see which ones are congruent. And I also have them listed for you right here. This is a time where you would maybe pause the video and write this down in your notes. You can see that those are all congruent. Then it wanted me to write a similarity statement. Again, I took FH and put it on top because that was in the first one on the left-hand side that I saw. I put that on top and I said, okay, so then as a ratio, that would be over JL, which is the same like side of the triangle in the other triangle. So all of them that were from this triangle, all of those sides, I put those on top. Continuing, which pairs of figures are congruent and which ones are similar? If they're congruent, they're the same size and the same shape. Similar just means same shape. So these ones are the same size and the same shape, so they're both going to be congruent and similar. For the next one, they're not even the same shape, so neither would be true. For the next one, they are the same shape, but they're not the same size. And for the next one, they are the same shape again, but they're not the same size. Example 3, it says, and this is where it gets a little tricky, find the scale factor, I'm reading the directions, of the drawing to the real painting. So drawing is going to come first, real painting would come second. That means I'm going to put the drawing on top. So the 9 would go on top, the 30 would go on bottom. Drawing came first, and though even though down here painting came first, we saw that first. In the directions, we want drawing to be on top. So 9 over 30. That's the same thing as if we did the width, 6 over 20. Both of these ratios are going to be simplified to 3 over 10. So that's our scale factor. On the next one, it wants to go to the model to the real sculpture. So the model is going to go on top, 8 over 32, which is the same thing as 7 over 28, which is the same thing as 9 over 36. And those are all equal to 1/4. So that would be our scale factor.